So today the subject is the heart, and I wrote a book about this called Human Heart, Cosmic Heart, and I have a website called humanheartcosmicheart.com. So if you go to that, you can see more information about this subject and things that other people have written about it. And the way that I got started with this was approximately 35, 40 years ago. I read that Rudolf Steiner, who is one of the people that I pay most attention to, said there's three things that have to happen in order for humanity to evolve in the proper way. And you can imagine a lot of things that you would put in that category. But the three things that he said were, number one, that people stop working for money. Of course, none of us work for money anymore. The second one was that people think there's a difference between sensory and motor nerves, which is a very obscure thing, which I'm not going to deal with. And the third thing was that people think the heart is a pump. Of course, everybody thinks the heart is a pump. And the question is, A, how can we conceptualize this to understand that the heart is not a pump? And then B, what does that have to do with saving humanity? Of course, it took me a while to figure that out, to sort of break the code. When you study Steiner, like I said yesterday, it's like being given the answers to the test, but you have to go and figure out how you get there. So after 30 years or so of trying to investigate how and why the heart is not a pump, then I think you can see why it changes everything. So that's the subject of today. Now, if you go to the website, you will see a couple articles. One is by a mechanical engineer named Ralph Marinelli, who wrote a book called an article called "The Heart Is Not a Pump." So that's a mechanical engineering. Do you want me to be here?
No, you can go wherever you want. I'll pick you up.
Okay. And then there's an article by an anesthesiologist named Bronco First. And there's essentially two people now in the United States saying the heart isn't a pump. There's me, I talk for lay people, and Bronco, who's an anesthesiologist, and he writes very technical stuff about this. And he wrote a book called The Heart and the Circulation, where he goes through, for those of you interested in scientific punishment, you can read that. And he goes into great detail of this. And the interesting thing is that the foreword to the book was written by the head of cardiac anesthesiology at Harvard Medical School, so presumably somebody who knows something about heart physiology. And he said, Bronco is correct, the heart can't possibly be a pump, and that's why we can't treat congestive heart failure better now than 50 years ago. And I say that only because I could be wrong. I've been wrong about a lot of things in my life, unfortunately. But if I'm wrong, apparently at least I'm not the only one. So if you look at this, and this is my technological diagram of this, what you can try to imagine this with me. So you have a heart, and then you have artery coming out of the heart, and then the arteries go down to the capillaries, and then they coalesce back into veins and bring the blood back to the heart. Now, I made a mistake in the book because I said that the person who said that the heart is a pump originally was a guy named William Harvey, who's considered the father of modern cardiology. But it turns out he didn't. He said that the circulation is a circuit. Heart, arteries, capillaries, veins, back to the heart. Just as an esoteric side note, the name of the arteries comes from the root word for Mars, and the name for veins comes from the root word Venus. So the heart is inserted between Mars and Venus in esoteric thought. So when you look at this as a circuit, and the first person who said that the heart is a pump was a guy who I'm sure most of you have heard of by the name of René Descartes, who said from now on we have to conceptualize everything that happens in living systems based on the laws of mechanics, that there are no other principles at work, And nowadays, you're only allowed to speak of mechanics and physical substance. And that all started with Descartes, who said the heart is a mechanical pump, and that's it. So when you look at this, interestingly, if you do a flow diagram and look at the velocity, the speed of movement of the blood is fastest here, right before it enters the heart. And it's actually approximately the same as the speed of the movement of the blood after it exits the heart. So the blood coming into the heart is moving very fast, and then it goes through the lungs and back to the heart, and the blood exiting the heart is also moving very fast. But the heart doesn't speed up the movement of the blood. So the first question you should ask yourself, if the heart doesn't make the blood go faster, what did it do to the blood? Now, when you continue on this, you see that the blood starts moving slower and slower and slower until it gets to the tissue level where there's capillaries. Now, the other fact to know about this is essentially one big artery and one big vein. And so imagine this is a river, and then it flows and starts making tributaries, and then it opens up into a pond or a wetland. And as you can imagine, it goes slower and slower and slower until it gets to the wetland and then essentially stops, right? Because anyways, it has to offload oxygen and food and pick up waste products and carbon dioxide. So it can't be whizzing through the capillaries. And then it starts coalescing, like a wetland coalescing into one central vein, and just that compression of the fluid from a wetland into a tube makes it go faster and faster as it gets up to the heart. You see that? So fastest stops here. The other thing you have to realize is that if you put all the blood vessels end to end, they would encircle the earth about 3 times. If you put them side to side, it would cover an entire football field, one next to the other. So this is a long push. And if you think about what you're pushing through this, let's just say halfway around the earth, you're pushing very sticky fluid in it with stuff in it, meaning red blood cells and platelets, which are approximately the internal diameter of the vessels. And when Marinelli did an analysis of the pump pressure, so let's just be clear what we're talking about. When we say the heart is a pump, we mean there's a pressure propulsion phenomena. In other words, the contraction of the muscle of the heart is generating enough pressure to propel this sticky fluid around the earth 3 times with stuff floating in it. And he estimates that the amount of pressure that you would have to generate to propel that amount of fluid is about 10,000 times the amount of pressure that a 1-pound, fairly thin-walled muscular organ can generate to push all this fluid around. So how does it do that? Not only that, it didn't make the blood go faster. Not only that, the blood gets slower and slower and slower until it stops. And then by some miracle, we think that the pushing here makes the blood stop here and then restart again. And the way that I describe that to people, it's like you want to go from a bus from San Francisco to New York City, and you're going to stop in St. Louis, and the bus doesn't have an engine in St. Louis. It stops to offload passengers. How is it going to get going again to go back up to the heart? Because anyways, any farmer or person wants to move fluid would, by definition, put the pump where the fluid has stopped, not at the top of the hill when the fluid is going to go slower and slower and slower. You don't need a pump there. Is that clear? Now, unfortunately, it gets worse. if that isn't bad enough. If you look at the outflow tube to the heart, so again, the theory in conventional science and medicine, this 1 pound organ, which when I say thin wall, some of the walls of the left ventricle, the final outflow, are fairly thick, like this thick, and some of the walls are about 1 to 2 muscle layers thick, which means you can stick your finger right through it. Interestingly, the part that's opposite the outflow tube is about 1 to 2 layers thick. Nobody would design a pump like that. But if you look at the outflow tube to the left ventricle, it's called the aortic arch. And when I was in medical school, I had a job being an assistant at cardiac cath lab. So we put the dye in, we watched the dye go through the heart. And what you see is, so left ventricle goes like this, the dye comes out, the blood comes out, it goes up the arch and then down to the rest of the body. Now there is a place where it goes up to the head through the subclavian artery. But interestingly, when you look at the anatomy, see if you can picture this, so you get this so-called pump, push, then the blood goes up, and then it goes down, and then it goes up to the heart. And when I first saw that, I said, that is a horrible design flaw. Why would you have the blood going up and then down and then back up? That's ridiculous. And not only that, but during systole, when there's so-called maximum pumping, so relax, contract, so-called pump, the aortic arch bends in instead of straightens out. Now, here's what I mean by that. Imagine you took a flexible garden hose and you put it on a spigot outside your house, and it's shaped like this. And you turned it off, that's diastole, and the arch was like this. And then you turned it on full blast, because you better turn it on pretty hard if you're going to pump this blood all the way around the earth. What would happen to this flexible garden hose if it could move? It would straighten, right? That's what would happen. Do you know what happens to the aortic arch during maximum systole? It bends in. And I remember I asked them, dear cardiologist, why does that bend in? That makes no sense. And he just said, because it does. There is no possible way you can generate that much pressure to push that viscous, sticky fluid, have it not increase the velocity, have it go to zero. Somehow that pushing is responsible for getting this going again, going faster and faster back to the heart, pumping real hard. The flexible tube bends in as if it's being suctioned, and we call that a pump. So I went from the idea of, I wonder if this is true, to I can't believe anybody believes this. This is nuts. There's other things, but I only have 40 minutes, so I don't have time to go into that. But those are the main highlights of how this cannot be a pump. So anybody, therefore, would know that the pump, and when I say pump, I mean the reason the blood moves, right? We're talking about what moves the blood in our bodies, in any living system. Has to be here, where the blood has stopped. You don't need a pump when the blood is already moving faster. So the next question, obviously, is what moves the blood, and what in the heck is the heart doing there in the first place? Right? What is it doing there? Obviously, it has a function. So what is the function of the heart in the circulation? Now, let's start with what moves the blood. So those of you who were here yesterday, remember that I said we were taught that there are 3 phases of matter: solid, liquid, and gas. But now we know that water, and only water, has a 4th phase. If anybody wants to read about this, Gerald Pollack wrote a book called The Fourth Phase of Water, where he proves this, which is an unrecognized gel phase. And I would contend that all the water in our cells is in this unrecognized gel phase, and that is the unifying principle of medicine. And for those who don't believe me, just realize that an MRI machine is a device that measures whether the water in your cell is structured or not. And if the structure deteriorates, it shows up on the screen and we say that's a tumor. If you have arthritis in your hip, it's because you have a gel protecting your hip. The gel deteriorates, and you see that on an MRI as an abnormal structuring of the water. This structured water, which is always negatively charged, has a different pH, has a different viscosity, you can prove it, you can measure it, always forms in the interaction of water and a hydrophilic, meaning water-loving surface. So if you can imagine, you put a beaker of water and you put a hydrophilic protein. In a very small layer next to the protein, there will be a negatively charged gel phase just because of the interaction of water and any hydrophilic surface. Now, if you imagine then this, where you take a beaker of water and you suspend a hydrophilic tube in the water, it will form a small negatively charged gel phase lining the inside of the tube. That's what always happens. You can measure it. Because of this formation of the negative charge, it separates the charges and puts the positive charges dissolved in the water in the middle of the tube. The positive charges repel each other and start flow. This explains the so-called barometric limit conundrum in botany, which says that a column of water in any column can only go up to about 33 feet before the weight of the column of water is too much and gravity makes it go down. Therefore, there are no trees higher than 33 feet, which is the problem with science, because that's the theory, but the observation of any human being is, but wait a minute, that tree is at least 200 feet. How does that happen? You can't have the sap going up the tree, that's a column of water, without it being too heavy and coming down. Except if you think about what is a tree, and you put this tube vertically, it's a xylem hydrophilic tube which has water in it. It separates the charges, puts the positive charges in the middle. The positive charges can't go down into the earth. They repel each other and go up, and that'll go up as far as you need it to. So this system allows you to understand a capillary is a hydrophilic tube, which with no other energy except what I'll say in a minute required, separates the charges, creates a negative gel phase, which by the way protects the vessel. It dissolves the positive protons charges into the middle of the water. They repel each other, start the movement, and as it coalesces into smaller and smaller vessels, like from a wetlands to a river, it by definition goes faster and faster and faster until it gets to the heart, and that's how the blood starts moving. Clear? It's exactly the system that works. Now, the next question, so what does the heart do? Well, the heart stops the blood. It's obvious. In fact, Rudolf Steiner said what the heart is like is a hydraulic ram. So what is a hydraulic ram? Hydraulic ram you put in fast-moving water, exactly like this. You put a dam and then a containment that can expand and contract, so it's a flexible containment vessel behind the dam. The water comes into it, expands the containment, the dam is still shut, and then you build up positive pressure on the incoming side, and negative pressure, i.e. a suction or a vacuum, on the other side. When the pressure differential gets to be too big, the gate opens, the aortic arch is sucked in because of this negative pressure. That brings the alignment of the blood vessel in direct alignment with the heart and the outflow of the heart up to the head. So it's not a design flaw. It's a perfectly structured system as long as you understand the suction effect. So the blood comes in, expands the wall, opens the gate, and then there's a passive contraction of the left ventricle around the outflowing blood with no energy required. That's exactly what happens. Now it gets even more interesting because if you then investigate what actually happens inside the left ventricle, you see what happens is a stopping of the blood, and then it creates a vortex inside the left ventricle. And this was first described by Leonardo da Vinci, who wasn't supposed to, but he dissected human cadavers. He made a cast of the human heart. He put water and wheat seeds through it, and he could see that the blood moved in a spiral formation, which is the formation of life, inside the left ventricle. Now, if you read the Sufis, they say there is a moment when the blood stops, and that's where God enters the human being. So here's what happens. The blood enters the heart. It's moving because of the properties of water. If you go back and read Harvey, Chinese medicine, all the rest of it, you say, why, if you ask them, why did the blood move? They said, because of the vital force present in water. Exactly. The vital force present in water, I'll describe that in a minute, moves the blood. It comes to the heart stops the blood. The heart creates an internal vortex, which is always the pattern that nature uses to bring energetic fields into and structure physical substance. That structures the blood to be an agent of the spirit. It's hard to say it any other way. And that distributes the blood to the rest of the body. It's so amazing even that there's little vortices inside the heart. There's about 50 of them, and they're all attached to different organs of the body. So one of the vortexes inside the heart is attached to the spleen, and it knows somehow to package the red blood cells that are old and send them directly to the spleen to be removed. Another vortex inside the heart, if there's a cut on your leg, it will dissolve some of the collagen fibers inside of your heart, put them in this little vortex, and send them to your cut on the leg to fix the cut on your leg. The heart is the orchestrator of all this, the energy of the world coming in, creating a structuring of the physical substance, and that creates life. I don't know how much more profound it can be than that. Now, the other thing that this changes is it changes your entire conception of disease. So, for instance, we know this disease called high blood pressure. So why do you have high blood pressure? So we don't know. It's idiopathic. But if you think along this line, so you have the blood flowing because of the ability of water to structure properly, right? Insofar as you have a robust movement and flow, then you have a strong flow of blood around the body. But if somehow this becomes weak, then you have a weak flow. And then I asked myself, and this changed everything the way I see the world and the way I see medicine, if I had a weak flow, what would I do to increase the flow? The obvious answer is to decrease the caliber, the diameter of the tubes, right? That would increase the flow. That's what we call high blood pressure. It's not a disease. None of these things that doctors treat are actually diseases. They're compensation strategies, or in other words, the best the body can do if you don't fix the flow. If you don't fix the flow, your wisdom of your body will narrow the tubes to create flow. Does it cause trouble? Yes, but that's better than having no flow. So now we have to get into the issue of, and this is where it gets fun because I get to harass everybody, which is one of my favorite things to do. So how do you increase flow? Which is the same question as how do you structure the water in the blood, because that creates the flow, as you all know now. But that same energy creates the structure of the water in your cells, which if distorted, your body has to create a fever to create snot to get rid of this distorted gel. If you have a distorted gel in your hip, we call that arthritis. So how does this happen? So it turns out that this is a very good system that Pollack developed to investigate this, because you can measure the flow. The stronger the flow, the greater the gel that's formed, the healthier, the more structured the gel is. You can also measure the pH, you can measure a lot of things, but the flow is easiest. So you put this in a lead box, right? Put it in a lead box, stops flowing. You take it out of the lead box and you shine the sun on it, and that starts flowing, because the sun is the ambient energy source that is used by the water. It's absorbed into the water to create this fourth or gel phase of water. You can put this out of the lead box and put it on the earth, and that will increase the flow, because there's an electromagnetic field from the earth which is absorbed by the water, which increases the structure of the water, which increases flow, which creates health. You can put your hands on the beaker, and we have an electromagnetic field from our hands, which is the basis of laying on of hands and touch, and why it's good to be with people, and that will increase the flow. You can put your dog next to it, at least most dogs, and that will increase the flow. And then here's where it gets fun. You know what happens if you put your cell phone next to it? The non-native electromagnetic field, the wireless radiation, we're talking about radiation here, immediately stops the flow and destructures the water. Anytime you have a wireless device in your body, on your wrist, against your head, you are destructuring the water and creating a fundamental poisoning of the very integrity of the foundation of life. Now, what do I mean by the foundation of life? So here's where this whole thing starts to get very interesting, because we're told human beings in medical school are only physical stuff, right? Never mind that if you look at an atom, which is the basis of physical stuff, there's a nucleus here, and over there by the end of the room there's an electron. So what's between here and here? Nothing. 99% of the atom is just space. And that's not even to mention that atoms exist in two forms, like particles, which are 99.9% space, or waves, which are no particles at all. So here's the question. How does 99.9% space mean I can't put my finger through my leg? This is just space. Physical stuff is just space. And nobody knows. But it's an interesting question. Now, here's another way to look at that. If you took a carrot, a living thing, and said, what is it made out of? To a scientist, and one of my favorite sayings is, the trouble with science is it's not very scientific. If you ask a scientist, what is a carrot made of? It's made of atoms. So 20 million sulfurs, 3 million hydrogens, carbons, etc., right? What if you go to a chemist and get a bag of all those hydrogen, sulfurs, etc., put them in a bag, put it on the table, it's a heap. Is that a carrot? No? Anybody think it is a carrot? Nobody, because that's stupid, right? Nobody thinks it's a carrot except your doctor, because he thinks you're only made of stuff. That's the stuff. Even though 99.99% of the molecules in you are water, which is a little bit more than a cucumber, which is 96%. So what's missing from the stuff? The heap. It's not alive. So how do you make it alive? Now, the other thing that's interesting about this is all stuff is subject to two forces, gravity and entropy, meaning if you take stuff and you do that, it falls, and if you leave it there 1,000 years, it will turn into dust, just like you will. But life doesn't follow those principles. A carrot or a tree creates form, so what's missing from the stuff is the form that makes it a carrot. How do you create form? You take an electromagnetic field from the cosmos, from the Earth, from Jupiter, from the sun, from the moon, and you shine that, you energize water. The water takes the stuff and brings it into levity and something that doesn't even have a word, which is called negative entropy or negentropic force. It creates form and life out of stuff, working through the water, working through these, absorbing the electromagnetic fields of the universe and creating life forms, which is the entire most important thing by far of any living being. That's where the action is, how you interfere or promote those life forces. Now, what's the time?
You still have about 13 minutes.
13 minutes. Everybody got this? There's a physicist named Erwin Schrödinger who wrote a book called What is Life? He said life is levity and negentropic force that works through water. Water essentially takes the substance up using the electromagnetic fields from the cosmos, creates life forms out of it, circulates the blood, protects your hips, creates the field, the energy around cells that allow them to keep their distance so that they don't collect into cancer cells. I wrote a whole book on how the abnormal water forces in the cell actually essentially create the cancer cell. So you can read about all that, but I don't have time for that now. So that's a new way of looking at medicine and life, and I think then you can see that the point of Steiner's the heart is not a pump is that gets you to have a whole different conception of what a living being is and what the heart is doing, including what diseases are. Diseases are compensation strategies.